Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do like, subscribe and share this channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, today's topic for the lecture is hydrogen bonds. As the name suggests, hydrogen is involved and it's a type of interactive force between two dipoles in which the positive pole is hydrogen and negative pole will be nitrogen or oxygen or fluorine. In whole periodic table, only nitrogen, oxygen and fluorine forms hydrogen bonds. Hydrogen bonds is of two types, intermolecular hydrogen bonds and intramolecular hydrogen bonds, and there is a certain set of conditions for their formation. So let's move to the screen for the detailed lecture. So what is hydrogen bond? Let us start. It is the interactive force. It is the interactive force between two polar bonds, or we can say dipoles, in which positive pole is hydrogen and negative pole is nitrogen or oxygen or fluorine. In the whole periodic table, only nitrogen or oxygen or fluorine can form hydrogen bonds. Now, hydrogen bonds is of two types. The first one is intermolecular hydrogen bonds, and the another one is intramolecular hydrogen bonds. Now, intermolecular hydrogen bond stands for hydrogen bond formed between two molecules. Let's take an example, that's hydrogen fluoride. Its example is hydrogen fluoride, that's HF. I'm taking two molecules of hydrogen fluoride. Hydrogen bonded with fluorine and hydrogen bonded with fluorine. Now, we know that electronegativity of fluorine is much greater than hydrogen. Then obviously fluorine will attract the shared pair of electron towards itself. Thereby fluorine will acquire delta negative charge and hydrogen will acquire a delta positive charge. And same goes to the second HF molecule. Fluorine will acquire a delta negative charge and hydrogen will acquire a delta positive charge. Now what's going to happen? These two oppositely charged poles will form interactive force with each other, and this interactive force is called hydrogen bond, and you can clearly see that the positive pole is hydrogen and negative pole is fluorine. Now let's take an example of one more intermolecular hydrogen bond, and I'm taking it to be water molecule. Water molecules. That's hydrogen, oxygen and hydrogen, and again hydrogen, oxygen and hydrogen. Now, we all know the electronegativity of oxygen is greater than hydrogen. Then obviously oxygen will attract the shared pair of electron towards itself. Thereby oxygen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. On the another hand, in a second H2O molecule also, oxygen will attract the shared pair of electron towards itself. Thereby oxygen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. Now, there will be the interactive force between the delta negative oxygen and the delta positive hydrogen, and this is again called hydrogen bond. And again it's between two H2O molecules, that's why it will be called as intermolecular hydrogen bond. Now let's move to the intramolecular hydrogen bond. What do we mean by that? Hydrogen bond formed within a molecule, within a one molecule, is called intramolecular hydrogen bond. I'm mentioning one very important point. During the formation of intramolecular hydrogen bond, comma, there will be formation of five or six membered rings only. Now, let's take an example to clear this point. What do we mean by that? Five or six membered rings only. The intramolecular hydrogen bond is formed in orthonitrophenol. My example for this case is orthonitrophenol. Its structure is, that's the benzene, that's the oxygen and hydrogen. After that, we are having nitrogen over here, that's the double bond O, and that's the coordinate bond with another O. Now what's gonna happen? We got the first dipole over here like this. Oxygen will attract the shared pair of electron towards itself. So oxygen will acquire a delta negative charge and this hydrogen will acquire a delta positive charge. On the another hand, this and double bond O. Here oxygen is more electronegative than nitrogen. So this oxygen will acquire a delta negative charge and this nitrogen will acquire a delta positive charge. Oxygen acquired a delta negative, nitrogen acquired a delta positive. What next? So there will be the hydrogen bond formation between this hydrogen and oxygen. So this is the hydrogen bond formed within a molecule. That's why we will call it as intramolecular hydrogen bond. Now let's talk about this point of ring. So in this case, we can easily see that here is the formation of hydrogen bond between hydrogen and oxygen. So there is a formation of new ring, and let's count the number of members of the ring. Count this hydrogen to be number 1, this oxygen to be number 2, carbon to be number 3, this carbon to be number 4, nitrogen to be the number 5, and oxygen with delta negative to be number 6. So we got this 6-membered ring after the formation of intramolecular hydrogen bond. It's a 6-membered ring. That's why this is possible. So let's take another example. I'm taking the example of para-nitrophenol. Para-nitrophenol. The para-nitrophenol does not form intramolecular hydrogen bond, and I'm giving its reason. Why para-nitrophenol does not form intramolecular hydrogen bond? Even there is a possibility. That's the benzene. Oxygen over here and take hydrogen to be here. The para position is this one. That's the nitrogen. That's the double bond O, and that's the coordinate bond O. Now, oxygen is more electronegative than hydrogen. It will attract the shared pair of electron towards itself. So oxygen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. Now, let's talk about the N double bond O. Oxygen is again more electronegative than nitrogen. So oxygen here will acquire a delta negative charge and nitrogen will acquire a delta positive charge. So here is a possibility of hydrogen bond between the H with a delta positive and O with the delta negative. So we got the hydrogen bond between the H and the O. I am marking with the green pen also. So now let's count the number of members of this new ring formed. This H to be number 1, O to be number 2, this carbon to be number 3, this carbon to be number 4, this carbon to be number 5, this carbon to be 6, nitrogen to be 7, and this oxygen to be 8. So we got the 8-member ring if intramolecular hydrogen bond forms in para-nitrophenol. But I have already told you that in intramolecular hydrogen bond formation, the new ring that have been formed, it will be only 5 or 6-membered. In the intramolecular hydrogen bond formation, the members of new ring formed will be only 5 or the 6. But in this case, we got 8. So this para-nitrophenol will not form intramolecular hydrogen bond. I'm repeating it again. For the formation of intramolecular hydrogen bond, the new ring will be formed and that ring will be 5 or 6-membered. But in case of para-nitrophenol, we got the 8-membered ring. That's why intramolecular hydrogen bond is not possible in para-nitrophenol. But in case of orthonitrophenol, we got the 6-membered rings. That's why it is possible in case of orthonitrophenol. So that's all for today. So that's all for today. I'm repeating it again. In periodic table, only the 3 members, that's nitrogen, oxygen and fluorine, can form hydrogen bonds with hydrogen. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.